Okay. So guys, today we're going to go ahead and cover 2.6. Um, uh, Good questions. I may go ahead and do a quick video for Courtney and I were just working a couple problems on 2.5. And so I might just grab those numbers and I'll just do a video for you guys separately if you guys are having problems. If you do have problems with any like homework sets, email me and I will work those. So today we're going to talk about combinations of functions and composite functions. Just to kind of remind you, composite functions, you probably have seen the FOG of X maybe in your algebra 2 down the road, but that's kind of where the composite, it's a function within a function. And when we do that, and when we start off, we need to have a firm grasp of what the domain is doing. And so on the first problems down below, they ask for the domain of f of x squared minus 9x plus 2. You guys are here. Do you guys know what the domain would be for that first problem? What would be the domain? If I put it up here as a graph, here's what the domain, here's what the graph of x squared minus 9x minus 2 looks like. So if I ask you, what's the domain? You would say what? Yeah, it's all real numbers because there's no restrictions. Now, obviously, there's issues with the range, right? The range is only going to go, looks like, I don't know, negative 21 maybe, but it's not going to go any further down than that. So there's restrictions on the range, but there's no restrictions on the domain. And so this one is going to be all real numbers. And so when I do that, let me see if I can get both of these screens kind of at the same time. Whenever I deal with domain and range, a lot of times I like to go ahead and just seeing the graph to me helps me understand what it is. Now, again, all real numbers, you can do the bold R, or you can say X is from for interval notation, negative infinity to infinity. That would work as well. Okay. But then let's look at the next one. Okay. Now notice that we've got a fraction, we got a rational expression. So I'm just going to put that one up there, and it looks like it's really kind of zoomed in there, kind of crazy. But if I ask you the domain, you'd probably say, oh, there's some issues, right? Tell me why. Can you kind of give me an idea of this one? Why does it look a little bit like that? Yeah, it has to do with the bottom of the fraction. What do you suppose these like for instance, there looks to me like there's two asymptotes. And an asymptote is just going to be a place where the graph is going to get really, really close to it and it's but it's never going to touch it. Okay? So there's two vertical asymptotes in there that's really not showing on my graph. Why do you think they're there? Hmm. What do you suppose is going to go on with that the bottom down here at this at this? If I say we're going to factor, then I say 15 is going to be the factors of 15 that add up to 8. You would probably be able to factor that, correct? And so factors of 15 that add up to 8 would be 5 and 3, right? 5 and 3. And then this time they're both plus. But but notice over here, it looks like that I have an asymptote at -5 and -3. All right. And it's the reason that you have a problem is because it makes the zero on the bottom of the fraction. And so in this case that I do have restrictions on my domain, X cannot equal -5 or -3 because that creates a zero on the bottom of my fraction. And that's why that domain is listed. So again, if I write it in interval notation, sometimes I like to do the -5 and -3 like a number line. And so I would go from negative infinity to -5, union of 5 to -3, -5 to -3, sorry, union of negative. Oh, you can't see the paper because I made my graph a little bit bigger. Sorry. -3, comma, infinity. So you could write it in interval notation. There's several different ways you could identify your domain for that. But any of those would be successful. But you just need to understand that there are problems. There are places in which the value of x cannot be. And in this case, and it's always going to probably, if you have a rational expression, you always need to look at the bottom of the fraction and say, are there some issues? Can x, if x makes the bottom, what values of x make the bottom of the fraction be equal to 0? Okay. But then we also have problems that like when we have like rational function or radical functions. So this is going to be just the square root of x minus 10. And so if I ask you again, domain, x can't be all real numbers, can it? Why? It does. And so I can't get any number underneath my radical that is, in this case, that is less than what? 10, because what happens is then it makes my y value less than 0. So it's, in other words, I can't have, when I have a radical expression, even though that we learned, if you have a negative underneath that radical, it just makes it what? What do we do when we have like the square root of a negative, when we did before, like the last unit, I had the square root of -25. Yeah, it was 5i. So we know we can write it as imaginary, but when we graph it, remember that goes back to that it doesn't, you have to change your coordinate system to be like that. When I gave you the video on the Mandelbrot set, you're changing it. You can't graph it on your rectangular coordinate system if it's imaginary. So I'm going to have restrictions on my domain for all radicals because I don't want anything. I want what underneath the radical, it has to be a positive number. So in this case, how would I write that in interval notation? So look at my domain. What's my smallest number I'm going to be for my x? 10 to infinity. Yep. Can it include 10? Can it be 0? Yeah. So I can go ahead and put a bracket and then I could go in parentheses. You could also say x is going to be greater than 10. So there's a couple of different ways you can represent your domain, but that's part of what we're working on today is combining those and looking at domain. Now, when we combine functions, when we add functions, subtract functions, or have the product or quotients, they also will result in a different function, and then that new function will have we'll have to look at the domain. Now, because of the fact that you can add numbers and subtract numbers, a lot of times this to me looks a little bit more. It says find f plus g of -2. Well, they've written out the f and they have the g. So if I look for just f of -2, so what they're saying is that if I write, let me start off with what they gave us. So it's f plus g of -2 means that if I find f of -2, that should also be plus g of -2. And so in this case, if I go back to my function as f is here, this is going to tell me I'm going to look to see when x is -2, what is the y value? So I'm going to go back and I'm going to go -2. The y value for f happens to be, okay, now it is right when I go, it's coming up here, 3. So that means I can replace f of -2 with 3. And then g of -2 is going to be then that -1. And so -3 or 3 plus -1 is going to be then just 2. And so you can separate those. If you wanted to find up what is the domain of g plus f, remember all of these values here will have a point. So if I were to look to see if I'm going to add these together, my farthest value here for x would be, to the left would be to 4, and then my furthest to the right would be then to 5. And so my domain is going to go from 4 until I hit 5. And so if I want the domain of f plus g, then I'm going to take my furthest left point, which is 4, and go till I hit my furthest right point, which is going to be 5. Negative 4, thank you. Negative 4, and I'm going to go all the way to 5. Now notice that at 4, it includes that point, so it's a bracket. And at 5, it also includes that point, so it's can be bracket. But sometimes you can see those, like if this one had happened to be an open circle, then you just put a parentheses. So when we find the domain of f plus g and f minus g, to me, when I look at this and I say, well, my f of x is going to be 5x plus 8, and my g of x is going to be x plus 6. If I want f plus g, then all I need to do is add them together. So that means I'm going to go my f of x, which is 5x plus 8. Then I'm going to add my g of x, which is going to be x plus 6. And I'm going to simply combine my like terms. So 5x plus x is 6x. 8 plus 6 is going to be then 14. So f plus g is going to be 6x plus 14. Now, they want you to determine the domain for each. So in the first one, if I just have a linear equation, and remember, if anytime you're questioning, what is it going to be? If I just put in 6x into my Desmos plus 14, what's the domain of any linear equation? Infinity, negative infinity to infinity, or all real numbers. So negative infinity to infinity would be my domain. Okay, if I go f minus g, the one thing you want to do, remember, if it's the whole thing, if I'm going to subtract f of x as x plus 8, or 5x plus 8, and I didn't put this in parentheses because of the fact that it was plus and I didn't need it, but when I do this for negative, I need to make sure that I distribute my minus, because I have x plus 6. That means that I'm going to need to distribute my negative into both of my terms here. So when I subtract them, I'll have the 5x plus 8 minus x minus 6. And so f minus g is going to end up being, yep. And again, I've got a linear equation, so my domain is going to be all real numbers again. And then my last one there, let's see, I've got 2 more to do. Boy, I didn't leave enough room. So it looks like on the next one, I'm going to multiply. So I'm going to have FG. So that means I'm going to end up with 5x plus 8. I'm going to multiply times x plus 6. Tell me, could you guys quickly tell me what it is? Yeah.
Plus 30x
Okay.
plus 8x, so 38x.
Yep.
Plus 48.
Perfect. And I don't have enough room at 48. Okay, so it's going to be 5x squared plus 38x and then plus 48. And again, you can put that into your Desmos, but quadratics, what do you suppose? All real numbers. Yeah, it's just, now again, just like the first one we did up here, you're going to have restrictions on your range. It's not going to be all real numbers, but your domain will be all real numbers. So in this one, your domain will equal then negative infinity to infinity. But we know that with division, you got to be a little more careful. So in this case, f divided by g will look like 5x plus 8 over x plus 6. Now, be careful. Can I cancel anything? Guys, I do see this still a lot, that people say I'm going to go ahead and cancel the x's. Remember, x is is connected, the 5x is connected with the 8, and the x is connected with the 6 with the plus. When they're added and subtracted, they're considered one term. So I cannot cancel those x's out and simplify them. So that's my answer, but my domain would have a restriction. What can x not equal? Perfect. Yes. So that makes the bottom 0. So when x cannot equal -6. And so again, you can write it in their interval notation where you go from -infinity to -6. And then union of -6 to infinity. I think sometimes goodness gracious, I am struggling because I didn't leave enough room. But you could also write it as x cannot equal -6. It's all real numbers except for 6. The next one, it looks like I'm going to struggle with this one too. So I'm going to flip over my page so I can have some extra room. And you guys may need to do the same, maybe put it on the back or something on our sticky note. So I'm going to, first of all, I'm going to add the two functions. So when I add the two functions, I'm going to have then f plus g. That means I'm going to have the square root of x minus 3 plus 2 over x plus 4. And in this case, really, the only thing I mean, to simplify this further is it would be a little bit difficult. I could combine the two fractions, but I'm really not going to get anywhere. But I'm going to determine the domain for each of the functions. So on the first one, I know if I'm going to just go ahead and put a number line right here. For my first one on my radical, x has to be greater than what? Yeah, or like think about if I go -3 here, here, let me just put it up here. Let me go x minus 3. I think you got the right, I'm gonna show you. 3, because of the fact that if you can't get anything less than 3. So even like if you think about x is equal to 2, 2 minus 3 is going to be a negative number inside there. So in this one, my number line, I know that x is going to have to be from 3 and it has to go on. But on the next one, it also cannot equal -4. So since the -4 is not part of my function, then I could say I can go, I can just say that it's going to go from 3 then until infinity. Okay, because my first one is not, it's not even, the -4 doesn't apply, even though that these values, I could get other values in here, but it's not going to necessarily mean. So my domain on this one would be just from the first one, that it's going to be from 3 to infinity. And it would include 3, and it would include then in parentheses. Now, if I do the minus, I'm going to do the same thing. So f minus g, square root of x minus 3 minus 2 over x minus plus 4 will be the same domain, correct? How about that? Does that help you? Help you? Sorry. And then the multiplication of that, when I multiply f times g, then I'm going to go 2 times, or I'll have the square root of x minus 3 times then 2 over x plus 4. And so in this case, I'm going to go then 2 square root of x minus 3 over x plus 4 would be my simplification. And again, same domain. Now, the last one usually will always give you a different, you have to check on that one. So I'm going to divide this one. So let me see if I can get some space. So I have f divided by g. And so in this one, I'm going to have the f of x, which is in the top. So x minus 3. And then I'm going to go over then g of x, which is going to be 2 over x plus 4. And you can't see that. How about there? Okay. So I have a complex fraction. So when you do the complex fraction, I'm going to just kind of show you real quick. When I have a problem, let's say that I have a over b divided by c over d. Okay, this really means a over b divided by c over d. That's the same, that you can write that the same way. But this, when you're dividing fractions, what do you have to? Yeah, so what you want to do is multiply the top times the reciprocal of your bottom. So this actually should be A over B times the flipping of this one, which is D over C. Well, so when it's a little more complex, I still have the square root of x minus 3 over 1, okay, because that's, you can always put something over 1. But then I'm going to multiply it times the reciprocal of my denominator. So I'm going to multiply it times x plus 4 over 2. And so this is really the simplification of that one divided. But you have to also remember your domain still needs to be considered from any part of the where we started. So, I mean, if I had restrictions on the domain early on, I knew it couldn't equal -4. It has to be greater than 3. So my restrictions on my domain are still going to be the same, even when I simplify it. Are there questions on that one? Kind of messed that up. I should have left a little more room. Now, composites of a function mean a function within a function. Okay, so if I have a function within a function, that means when I have f composite g, that means I have f of g of x. And I'm going to make it a little bit like this, because what I'm going to do is I'm going to substitute into my f of x g of x.
Okay.
Okay, so if my f of x, so f of x, remember, was the square root of x. So now when I look for f of g of x, that means I'm going to replace the g of x with x plus 7. That means wherever I see my x, I'm also going to replace it with x plus 7. So f of g of x is just the square root of x plus 7 in this case. Now, a lot of times they will ask for the domain on this one, but again, so just check your work. Like on this one, the domain would be numbers greater. Okay, now, yeah, so -7 is correct. So -7 makes it 0 or bigger. So good job. All right, so on this one, if I go g of f of x, that means g of f of x. That means inside of g of x, I'm going to now put f of x, and f of x was the square root of x. So really what I'm wanting is g of the square root of x. So if g of x equals x plus 7, that means I'm going to replace that x with the square root of x plus 7 is g of f of x. Do you remember doing these in kind of, how about you, Courtney? No, this is new. Okay. Does that make sense? Kind of when you substitute them back in. Okay. So when I do f of g of 2, if I found f composite g of x, then and I know that it is already f of g of 2, then it's going to be the same thing as the square root of, I'm going to replace this 2x with 2 plus 7, and then I can go ahead and simplify. So I have the square root of 2 plus 7, which is square root of 9, is 3. And I found f of g of x, which was the square root of x plus 7. So if I want g of f of 2, and I knew what g of f of x is, then I can replace the x with 2 plus 7. Now, when I have the square root of 2 plus 7, I can't do anything more because I can't. That's just going to be your answer. So what you want to do, if x is not a domain of g, and it must not be a domain of g of f of x. So we have to remember that whatever restrictions were there before you put them into your composite, they're still there when you find your composite. Okay, so when I look at the square root of x, I know I have restrictions on my domain. And so that those are going to stay even if I substitute them back on. or if I change it. So on this one, if I have f of g of x, and they just change it. So I'm going to go f of g of x. I'm going to replace the g of x with x minus 7. And then I'm going to look at f of x is the square root of x. So that's going to be the square root of. So inside my x, I'm going to change it to x plus 7 or x minus 7. And then the domain, you will figure out the domain is going to be then. So that's my composite. So on this one, I went 7 or greater. Now, do check because the first one on the domain had to be just greater than 0. And in this case, the new one, if I go 7 greater, it still will take care of all of the things that were behind it. If it ever doesn't, then you need to go back to one that includes make sure that both of them are included. All right, let's try the last one. And this one's just a little more complex because it deals with a complex fraction. So if I want f of g of x, so I'm going to start off with f of g of x. I'm going to replace I'm going to replace my x. I'm going to change it to 3 over x. So my f of x is 5 over x plus 5. So that means I'm going to replace this x with 3 over x. So I'm going to rewrite it. So my top part of my fraction will just be 5. But then my x now is going to change to what? Perfect. But then I have plus 5. Now I need to simplify it just a little bit. And so first of all, I have two terms. And so I want to think about this in terms of I want to combine these two, like the fractions. So if I make this 5 over 1, my denominator on the bottom, okay, I'm going to just go ahead and put it right here. So between these two terms, my least common denominator just is going to be x. So that means that on the first one, I don't have to multiply the 3 times anything. So it's just going to be 3 plus 5x. Good job. Because I'm going to have to multiply this one times x over x. And that's where I'm going to get the 5x. Now I still have over 5. Now, remember, I can also write this as 5 over 1. So I'm going to go 5 over 1 times the reciprocal of my denominator. So I'm going to flip it. So it's going to end up being, yes.
No, you can't.
Nope, you can't. Very good. And that would be your answer. Now, they ask about the domain. Well, obviously on this one, that x cannot equal, if I solve this, this bottom part of the fraction cannot equal 0. So let's find out where makes it 0. So 3 plus 5x is equal to 0. If I move my 3 to the other side, I would have, goodness, 5x is equal to negative 3, and x is going to be equal to negative 3/5. It cannot equal negative 3/5 because that makes it 0. So x cannot equal negative 3/5. But remember before, I want to think in terms of all of the problems I've had before. X it couldn't equal 0 either, could it? So let me start out here. I know that if I'm just going to put my domain, x cannot equal negative 3/5. But from the start, x couldn't also equal what? From my f and my g. It cannot equal 0. And it also cannot equal, right. So in that case, so I'm looking for my domain on this. And so if I go ahead and just kind of quickly put it in real quick, let me show you real quick on what it. So on this one, whoops, 5x. 5x divided by 3 plus 5x. It looks a little bit like this, where I've got that asymptote that's going to kind of create at -3/5. But remember, it also cannot equal -5, and nor can it equal 0. And so in this case, you would have to restrict those as well. And so I would go ahead and say that I'm going from -infinity to -5. And a union of from -3/5 to 0, union 0 to infinity. So I'd want to go ahead and make sure I include those, even though they're not really a restriction from, if I graph just my composite function, it doesn't look like it's really restricted, but I need to remember that it still is from the originals. Does that make sense?
Yeah.
Perfect. All right. Well, that takes care of our lesson